Very good morning, dear students. I am Shomadeep, and I will be your faculty for the subject of robotics. I welcome you all to this course, in which we will explore the immense possibilities in the subject of robotics. Now, what is my purpose? What is my purpose here? My purpose is not to cover all the topics over here because robotics is a vast field. We cannot go through each and every nitty-gritties of each and every robots there are in the world. That's not possible. So what is my purpose of life? My purpose would be to give you that knowledge by which you can build different kinds, different types, and various classification of simple robots. So in this course, and along with this course, what I will teach you all the basics from scratch level to difficult projects level. I will teach you in the very first lesson that is now it's happening, the introduction to the subject of robotics. Now, what do I mean when I say introduction? The introduction basically deals with what robotics is. Do we actually, in our daily life, apply the knowledge of robotics? Do we want to apply the knowledge of robotics? What are the kinds of robots? What are robots basically? All these queries will be answered in this particular session. Now that is what is known as introduction. After that, what we will do? What is the purpose of this course? After this session of introduction, we'll be moving on to the various nitty-gritties, various applications. To be specific, we'll be holding on to a microcontroller. What is a microcontroller? Is the brain of your robot. You can say it simply. Like for people who haven't heard about microcontroller or anything, no need to worry. If you know what it is, if you know what are the sensors, well and good, very good. It will help you out. If you don't know what sensors do we use, what are the different purposes of the sensors, what are microcontrollers, how to connect, what are the circuits, what are the circuit diagrams, no need to worry. I am here to help you all regarding all of it. And that is why at the beginning, I said that I will be starting from the scratch and will go to the projects level. I'll be giving you projects. Now, what kind of projects would it be? You might be wondering that. So you said that there are thousands and if not lakhs kind of robots in the whole world, right? What we're going to do, we will be holding on to a microcontroller, as I said. We will know how to program it. What is program? You all might be knowing about it. So a program is basically instructions, group of instructions, right? For example, I am talking in English right now. I'm communicating in English. So if you understand English, if I can speak English, then we both can communicate between us. In the same way, people who don't know what programming is, or they might be not be knowing what programming languages are. In the same way, it can be defined that a computer is there, you are there. Now you can speak English, but the computer cannot understand English, right? Okay. So you need a very basic mode of communication between both of you. And that is what the sole purpose or the core purpose of any programming languages in the whole world is. Okay. To communicate with the machine, right? What is a machine? We all know that, right? It's a very famous thing. We all know that. Now, what is the other purpose of this course? What is the main purpose? Because you might be wondering, sir, we all have our courses. We all have our courses outlined in our schools and colleges. Now, why do we need specifically to study this course of robotics? Why do we need it? You see, only studying the course curriculum, only studying the course curriculum, being an engineer in my part, I can tell you, it will only help you up to a specific limit. What we in Agriculture Academy want, we want you to go beyond that limit. We want you to stand out of the box. We want you, we want people to distinguish between you and other students who don't study out of the box. Okay. I think now our purpose of this course, our purpose of studying or teaching this course is absolutely clear to me. Now, when we talk about robots, one thing we need to be very, very clear. The daily idea our robot is by what we generally have an idea from. We generally have an idea from by watching movies, by watching series, right? You might be knowing the Indian robot that we have seen. Okay, you might be knowing, you might be have watched the movie I Robot, right? Right, that's a Hollywood movie. We all got a very good idea of robot consciousness, right? We had a very good idea. Okay, what are all these things that we are going to study? If you see in this diagram of our robotics, there don't you find somewhat similarity of the human evolution with the diagram present over here? What is the similarity? If we imagine a robot to be a bipedal robot, what do we mean by bipedal robot? It's a term that we generally use. Bi means two and pedal means legs. So a robot having two legs are generally called bipedal robots, right? So when we say robot, we generally refer to a bipedal robot because we are habituated to see it in movies, right? But is it that easy to make? Is it? Question yourself. It's not at all easy to make it. Okay. The balancing, there are numerous amount of sensors working all together, sending the data to the controller. It's getting processed. It's a huge process. Trust me on that. Even I wanted to build a bipedal during my college years, right? It's not at all easy. So what we are going to do, we are basically going to program with a certain kind of microcontroller. We will be keeping it in hand, and then we'll be integrating the sensors. What are those sensors? It can be hundreds and thousands types of sensors. Some very basic sensors are ultrasonic sensors, you can say. There are LDR sensors. There are RxTx sensors, accelerometer sensors, gyroscopic sensors. All these kinds of common sensors that we use, we will be integrating it with the controller using various kind of wires. We'll be giving it a power supply. Anything cannot run without power supply, right? And then we will be building a very basic body mind. Okay, you can do it at home. Okay, by purchasing the basic structure, basic chassis, we say. Okay, and then what will be my purpose over here? My purpose would be to make sure that you understand what you are doing in the programming part. What instruction, if you yourself don't understand the instructions, the robot will not. Okay, it will just follow instructions. It's kind of a soldier, right? That you are programming, that you're instructing. My purpose will also be to show you the circuit diagrams, how to connect. My purpose will be to fulfill your desire of making the robots by your own. So let us get started with, since this is the very first class, we'll be having an introductory session. In the introductory session, we'll not be learning any project in specific, but what I'll do, I'll give you a very good idea how we are going to proceed in the robotics part. In the next videos also, I'll be giving you the content display fully. Okay, so let us get started with. So here we are. Let us go into this PPT and let us see basically the introduction part of robotics. Introduction. Now this is what the idea, why I have put this picture in place, because this is what is the idea we generally have of a robot. All right. Someone like a bipedal humanoid robot thinking by its own. That's a very tough job to do. Okay, so let us get into the presentation right now. What is robotics? Very simple definition for all of you. What is robotics basically? Robotics, it is the interdisciplinary study. Why it is called the interdisciplinary study? Because you see, it's not only one group of people that can study robotics, right? There are many departments that are associated with it. There's mechanical engineering, there's electronics engineering, very much computer science engineering, IT, every other thing is associated with this study. All the things comes together and makes it an interdisciplinary study. So it's an interdisciplinary study and practice of design, construction. First, need to make the design, right? Without the design, nothing is possible. So design, construction, operation, and use of robots. So first, basically, you need to know the uses of robots, where and how you're going to use it. Without the use, the robot is of no purpose. You cannot, you can actually, but you don't want to make a robot just for display, right? It's not a prototype, it's a robot. It needs to work. That is the whole purpose of a robot. A robot, basically means slave. I know it's kind of derogatory, but it basically means slave, the word robot. Okay, all right. Now, why robots? Why do we need robots? This is probably one of the most important slides we are going to study today. Why we need robots. You see, I have added 9 points over here. Point number 1, productivity. It's a very easy to understand point. This is why we need robots for productivity. We basically, yes, there is a possibility of increasing the productivity, but in any industry, human effort is a very costly and very much efficient thing, right? If you increase the labor, then only you can get more of efficiency. Might be a man has a limitation, right? A woman has a limitation to work this many hours. We have labor laws and things in place, right? Why? So that people cannot exploit the laborers, right? By exploiting, what do you mean? Making them work overtime forcefully, might be exploitation, right? To avoid all those things, try to understand, if an industry requires a certain amount of things to be made within a certain amount of time, but the human beings are not sufficient to make that certain amount of things. What if we inculcate a slave over there? What if we inculcate a helper over there? What if we inculcate a robot over there? It will immensely increase the productivity of the industry, right? So industrial robots are one of the most important robots, one of the most important things that we have done in the past few centuries. Okay, let us come to point number 2, safety. And you see, health hazards, technical hazards is always a possibility in industries. Okay, you might have heard about health hazards like the Bhopal gas tragedy. It was a devastating event. Like, so many lives were lost. Now just think for some time that in place of people, if there would have been some robots working, or robots monitoring the gas chambers, or robots monitoring the temperature, whatever it might be, would there have been any health hazard? No. We can totally eradicate the possibility of health hazards by controlling the robots. by giving work to the robots, by employing the robots basically, right? So safety is a very important point of the topic, why robots, right? Like, why do we need robots? Point number three, cost effectiveness. Now you might be wondering that, sir, how can you inculcate the point of cost effectiveness in why robots? Because you see, basically what we have, the industrial robots, they are very much costly. They comes in lakhs and crores of rupees, right? But don't you think maintaining or giving maintenance to a huge number of human beings is much costlier for years if we see than inculcating robots? That is what my point is, right? Cost effectiveness. Now, you also might be wondering that, sir, robots need servicing, they need maintenance. What about that? Why aren't you saying about that? Yes, I will be saying about that. The thing is, the more you see, there is a kind of ratio that is built upon. The more costly or the more efficient the robot is, the less maintenance it needs. Okay, we'll come to that later. Fine. Number four, hazardous environments. I already gave you an example of the Bhopal gas tragedy happening, right? And the MIC gas getting leaked and all. So hazardous environments, to prevent hazardous environment, to prevent the health hazards, robot is always the best solution, the best option. Okay. Flexibility and speed. See, first I'll talk about speed, because the way, for example, I am speaking 10 words a minute. Just for example, I'm talking about. Okay, don't now count my words. So I may be speaking 10 words a minute, right? So I will be definitely having a time constraint factor because I'm a human being. I cannot speak more than that, right? I'll have to breathe. I'll have to wet my windpipe. But a robot can do that. If you are like familiar with some kind of bots or GPTs, what you will see, they can generate a huge number of words within a few minutes. So speed is a very important factor when on intelligent robots. And then there comes flexibility. There are many things that human might not be able to do, but a robot can do that. So that's how flexibility comes into play. Accuracy, or we can also say precision. That's a very important factor, right? You agree with me, right? If I can draw a circle, it might have some fault, and most of the people, we are unable to draw a full-fledged circle, right? But a robot can. How? Because they work on measurements, they work on coordinates. We'll come to that later, and we'll study the types of robots, right? So accuracy or precision is a very important factor while studying robotics. Why we can get robots in our uses. Then we have assembly robots. Assembly robots, they speed up. Again, it's connected to the topic of speed. Consistent quality. Humans can make errors. If I make 10 bowls, okay, 10 of them can be somewhat different from the other, from the previous one. But if it is made by a robot, all of them definitely, for sure, have the same measurements. Definitely, right? So consistent quality, right? And then finally, the ninth point, I don't know it's visible to you or not, error reduction. See, it is also related to the sixth point, that is accuracy or precision. The more precise, the more accurate it would be, the product would be, the less there will be the error. Okay, you can totally eradicate error by using a robot. Now, there's a bit of history, and you might be knowing the structure that is present over here. Okay, so what is it? It's the Iron Man. Now, why I have included the Mark II, the most earliest one built by him, because it's kind of a history. Let us read out. The first digitally operated and programmable robot was invented by George Devil in 1954, right? And it was unanimously called the Unimate. Okay. All right. Now, this unanimously laid the foundation of the modern robotics. Okay. There is always must be a foundation, very strong. Okay. Devol, what he did was he sold it to the General Motors, okay, in 1960. And in 1961, the plant in New Jersey, they inculcated the robot. Okay, that was a brief history about robotics. You can always go to the internet and you can search. Uh, you see, there was patent for the first digitally operated programmable robotic arm. It represents the foundation of the modern robotics industry. Because when we talk about industrial robotics, when we talk about industrial robots or assembly line robots that we are going to study now, we always mean to show you by diagrammatically or schematically the robotic arm that are used. All right, I hope you understand. Next, how can we classify? This is one of the most important slides, dear students. How can we classify the types of robots? Number one, there are industrial robots, right? We'll be seeing that, don't worry. We'll be seeing, I'll be showing you all the diagrams so that it becomes very easy for you to understand, okay? So industrial robots, all right. Number two, articulated robots. Number three, there are vehicles. By vehicles, I mean autonomous vehicles that are very famous nowadays, right? Number four, Cartesian coordinate robots. Okay. Number five, aquatic. Now, what do we mean by aquatic robot and how it is different? The construction is very much robust. The construction is very much different from other robots. And number six, medical robots. Again, it is based on the use that I'm doing over here. Okay. Then comes SCARA. I will tell you what it is. Okay. Then comes service robots, spherical coordinate robots, cylindrical robots, autonomous vehicles again. Okay. And degrees of freedom robots. We'll be going into all the nitty-gritties, okay, in today's class also somewhat and in future class also. So this is what an industrial assembly line looks like. This diagram is very famous, I know, right? You all might have seen it in many channels, many TV channels, or it might be if you're a movie fan, you might be seeing it in many movies also. Okay. So industrial robots, what do we do? They are the most important parts when it comes to assembly line, because assembly line requires speed and precision all at the same time. So it's not a job for the humans, right? And it might be dangerous also. Think about it. Okay. Articulated robots. Now, an articulated robot, what it is? They have rotary joint. Now, don't worry if you don't know about rotary joints. Okay, we can always study it in the future classes. Okay, the second class I'll be giving you. I'll be telling you some of the details of this robot, and then we'll be moving on to our main purpose, that is to program the microcontroller and then build the products. Okay. Now they have rotary joints. Rotary joint means which can rotate, right? Okay. Now, what are the purposes, main uses of these articulated robotic arms? Material handling, welding. Welding is a very important job that they can perform, right? It's also very dangerous for human beings to perform. Okay. Assembly, that is in assembly lines they can be used. Okay, very well. And machine tag. Then comes the purpose of autonomous vehicles. Now, I have included a very cartoonish picture of someone. You must be recognizing him, okay, who has begun the revolution in autonomous vehicles. Okay, what is autonomous vehicles? It's a robot that operates, keeps you safe while driving. Like you don't need to drive it. Okay, it will reach out to your destination, right? So this is the man behind it. Okay, why I have included the picture? Just to remind you that yes, there might be many things you are hearing on the internet on the daily basis or anything. Okay, but the thing is, he is very much passionate about fully autonomous, making the vehicles fully autonomous. Okay, all right. Then comes Cartesian coordinate robots. What do you mean by Cartesian coordinate robots? See, we know what is Cartesian coordinate system is. We have the x-axis, y-axis, right? Okay, we move along the axis to locate a point particularly, right? In a 2D plane, if we give a certain value to the x-axis and we give a certain value to the y-axis, then we can locate a particular point in the xy 2D plane. That is the whole purpose of this Cartesian coordinate robot, okay, using the Cartesian coordinate systems. Now, then comes the aquatic, right? You see, classification can be based upon many factors. One of the factors being the uses or place of uses. So aquatic robot is basically classified based on the uses, that is underwater. Why it is a different classification? Because the construction you see must be very much different, must be very much sturdy to avoid. See, any circuit can get damaged by water, right? So it must be a very sturdy construction to avoid those, because it will work under immense amount of pressure. It might be used to repair underwater sea line, underwater lines, underwater pipelines, right? Many uses. Okay, that's why it's a totally different classification for us. Then comes medical robots, very important. Now you see, doctors are very important, right? They perform surgery, they're very important purpose. Now a doctor might not be able to reach at a certain place at a certain precision. Who will help him or her? A robot can. If you fix the coordinates, if you fix the location, it can precisely operate that area and it can help, right? Very important, not only in operation but also in other purposes to detect certain things. Detection robots are also there in medical purpose. Okay, now what SCARA? About SCARA will be not SCARA, actually we pronounce it SCARA, it is SCARA, the acronym. We'll be studying it in a different session. I'll be telling you, don't worry about it. Okay, it needs many things to be done. Then spherical robots. Spherical robots, they are not actually spherical robots, they are basically spherical coordinate system robots. You see the operating area are denoted by in this diagram. Why I have included this diagram, dear students? For you to understand the operating arena, the operating area of the spherical robots, right? It's a spherical coordinate system. If you don't know what a spherical coordinate system is, absolutely okay. No issues, no problem, no need to worry. It's just that in a Cartesian coordinate system, we work in a 2D plane, whereas in a spherical coordinate system, we work thinking that this sphere is the working arena. Okay, that's it. Okay, that's it. No need to worry. Similarly, there is cylindrical coordinate system also. You can always search these things on the internet. Okay, that's a very good source, right? So cylindrical coordinate system is also there. You see the operating area not denoted by dotted lines over here. Okay, it's denoted by the thin lines, thin black lines over here. That is the operating area. So it will be, see, a cylinder has two things, too many things. Okay, one is the radius due to which the circle is constructed, and then the height. If you take a circle, there is a 2D diagram, and give it a height, it becomes a cylinder, right? Right. So this cylindrical coordinate system robot must work based on the radius, right? It can increase and decrease the radii. Okay, you can see the actuator over here, and then the height. Clear? Okay. Now, way forward. So this is all about today's session, where I gave you a very brief introduction, yet interesting, of course, about the field of robotics, right? This diagram that is present over here in this particular slide is from the movie I, Robot. Okay, it's one of my personal favorite, that's why I've included it. Now why I've included it in the end slide is that just to make sure that you understand our purpose. Okay, our purpose is to learn it from the scratch and to go beyond what we know by now, right? That is our purpose. Okay, I hope you have enjoyed the session. I enjoyed it thoroughly. Okay, thanks to all of you being so attentive in the class. Now I'll be giving you some works daily. Okay, we'll be starting it. I'll be giving you some questions, maybe. Okay, some projects to build at home, so that the continuation remains at home also after the class. You don't forget it. Okay, for today, since it was the introductory session for robotics, we really didn't go into the microcontrollers and programming section. There would not be any such kind of homework, although I can give you one question, okay, to ponder upon. The question would be, you can note it down, who and why is known as the father of robotics? Okay, who is known as the father of robotics and why? Okay, This would be a question, a very simple thing to do. Okay, it would take 5 to 10 minutes from yourself, okay, from your side. So think about it. Think about the purpose why we are studying this. Think about what we are going to study, and let us meet in the next classes, in the next sessions, where we'll be straight away going to the microcontrollers and programming session. Okay, so thank you all. Yeah, this is one of my favorite robots. Okay, so thank you all for being so attentive. We shall again meet in the next classes.